Hello, hello. We're going to do another Leetcode question today. My name's Sam, and I'm going to be running through this as if I'm getting mock interviewed. We're going to choose a random, easy Leetcode question, and I'll start the timer over here on the bottom right. And let's see what we get. I'm also using a gdoc just because sometimes you don't get access to an IDE when you're doing an interview with some companies, or the IDE they use doesn't have the same highlighting and so on that you might be used to. So just kind of get used to losing those advantages. Specifically for the interview, I sure hope you never have to do real coding without an IDE, because it definitely does make life a lot easier for everyone involved. All right, so let's get to work. 2942, find words containing character. You're given a zero-indexed array of strings, words, and a character x. Return an array of indices representing the words that contain the character x. And this returned array may be in any order. So let's say we have leet and code, and the letter is E. So the indices 0 and 1. And it's kind of interesting that you don't even need to return the output in any order. So, first glance, this is some sort of iterating approach. Iterate through words, check if character exists. So the idea here is, let's just turn this back to normal. Build a pointer array, index array, and return that. So we could do that. I'm gonna actually just kind of start off with that before let's think about some other approaches. What else could we do? Is there any reason to sort the array first? I kind of like this because this will be O of n words for n word, O n 10 words, O of n space for n in point to indices. That's ideal. You can't ever do better than that. You have to check every single word. We're not given the words in any specific order. The lengths all fit in memory. They're all lowercase. Okay, so I think O of n time O of n space is optimal. You can't really do better than that for big O. You could maybe for median O. Maybe not. I think on average it'll be a lot less, because you're depending on if it's in on average it would be like theta n and the number of if the number of characters is k, you could say like k times n for something like that, and theta would be something along the lines k over 2 times n, which ends up being the same thing, because you're assuming average probability of finding the letters somewhere inside there. Okay, but we're not going to go with that, so let's just move on. That becomes O n log n, assuming you use quicksort. That's worse. And you're still going to have checks. So yeah, I think we're just going to stick with approach 1. I don't want to complicate this too much. We're about 3.5 minutes in, so let's just implement this. So what do we got? We're going to call this find words. And our input is going to be words, which is a list of string, and our output, and we're going to get our x, which is our character, which is, in this case, we can call it a string or a char. And our output is a list of ints for the indices. And what I'd like to do for word in words, we're trying to get, I'm going to do a one-liner just for being clever at the moment. We enumerate over the words. That gives us our indices. So first of all, this would just give all the indices, and now we just check if x in word. That is the one-liner where we're iterating through all of the words. We're keeping track of the index I, and we only return that index if that character x exists inside the word. And this in check is kind of a O of k for k characters in a word check, assuming x is a single string, a single character. This might be enough. We can spread this out in a minute, but let's have a look at this. I just want to see if this even works. Can you guys see all this? Oh, I should have checked. Well, it passed all the test cases. Let's just check. Do we have to worry about empty strings? No. Empty words? No. In fact, it would be okay for an empty number of words. It would return an empty list, which in this case I think is accurate. If X was empty, then it would always be true, I think. So that would be accurate too. So yeah, let's submit it and see what we get. Yep, passes. It seems to run at average time. I think there might be some interesting optimizations to make with C backend type stuff. It's definitely one of the shorter ones. We're only about 5-6 minutes in. Trying to think about what I would rather do differently here. Assuming there's only a single character, let's think about how in works for a string. So Python for 2 strings is going to do something that's more O of K, but we know it's a character for sure. Let's see, is that how that works? I'm not entirely sure. Yeah. Yeah, it's about the same. That doesn't really change anything for string versus char. Well, let's try. Let's pull it out. I'm just to avoid doing these kind of clever things. Maybe if we made the problem more complicated than a single if check inside of, maybe it's a sequence or something like that, you'd want to be able to pull it out. Output isn't empty, and so if X is in a word, output append I and return output. So this is exactly the same thing now, but just pulled out into a full separate sweep. So now we can say there really isn't much more to be done here. You could iterate over the words. This is not any better. This is in fact going to be a lot worse, I'd say, but this is doing a character by character iteration through a generator for a character in Word and checking if that character is equal to X. Maybe in C++ or something you'd have to implement this manually. You won't, because they have that too. Yeah, I can't think of anything more to do here actually. So this was a pretty quick one, but hopefully it was interesting to you all, and see you guys next time.